Hello friends, welcome back. In this video, we are going to do question number 3. So let us start. ABCDE is a pentagon. Calculate AD and show that it rounds to 94.5 meters correct to one decimal place. So in triangle ADE, we can see that angle EDA is equal to 90 degrees. So therefore, and we have the adjacent side and the opposite side. So tan E will be equal to opposite by adjacent, and here the opposite side is AD divided by the adjacent side. So 46.1. That implies tan 64 degrees is equal to AD by 46.1. So AD will be equal to 46.1 into tan 64 degrees, and if I calculate the value, this will turn out to be 94.519007 and so on. Now if I cut it to one decimal point, since 1 is less than 5, everything will go out and it is 94.5 centimeters. That's it. We have already proved it. It rounds up to 94.5. Second point, calculate angle BAC. Calculate angle BAC. Now we have this angle and its opposite side. We have the opposite side, but we need to calculate this angle. So we can use the sine rule. In triangle ABC, using sine rule, what will happen? So which two sides do we know? We know the sides AC and BC. So AC and BC. AC and BC. So BAC divided by BC. And what are the angles that we know? We know that BC is equal to 56.5, AC is equal to 78.4. And which angle do we know? We know angle B is equal to 94 degrees. Therefore, from this I can write that sine, that implies sine angle BAC divided by BC, which is 56.5, is equal to sine 94 degrees divided by 78.4. So therefore, sine of angle BAC is equal to 56.5 into sine 94 degrees divided by 78.4 degree, 78.4, and this sine value is equal to 0.71890,776 and so on. So angle BAC will be equal to sine inverse 0.71890,776 and so on, and this value is equal to 45.964377 in degrees. So if I cut it at two decimal points, the answer angle BAC is equal to 40.96 degrees. Because 4 is less than 5, 6 will remain 6. It will not change. So that is the required answer. Now let us go to the next part. Calculate the largest angle in triangle CAD. So in triangle CAD, what do we know? We know all the three lengths actually. In the first part, we have calculated that this length is 94.5 centimeters or 95.4 meters. So be very careful, I have used centimeters here. So these are in meters. Okay. So this is, we know AD is equal to 94.5, CD is equal to 38.6, and AC is equal to 78.4. So AD is equal to 94.5 meters. Then DC is equal to 38.6. CD is equal to 38.6 meters. And what do we know? AC is equal to 78.4 meters. So the largest angle is triangle ACD, which is opposite to the largest side AD. So therefore, cos of angle ACD is equal to CD square plus AC square minus AD square divided by 2 into CD into AC. This is equal to 38.6 whole square plus 78.4 whole square minus 94.5 whole square divided by 2 into 38.6 into 78.4. And if I calculate the value, this value will turn out to be minus 0.213752 and so on. So therefore, angle ACD is equal to cos inverse of this value. And this angle is, since the cos is negative, so we can see that the angle is in the second quadrant. So it is actually an obtuse angle. So the angle is 102.342323 degrees. And if I cut it at 2 points after the decimal, it is 102.34 degrees. And that is the final answer. This is how you solve. When you have 3 sides, you will use the cosine rule. That is the easiest way. Okay. So let us go to part B. Triangle PQR has the same area as triangle LMN. Calculate the shortest distance from R to the line PQ. So what do we know? Area of triangle LMN is equal to half into LM into MN into sine M. And since we have this already, we can calculate this value directly. 27.6 into 21.5 into sine 111 degrees. And its value will turn out to be 276.9933, 12542 and so on. And this is the value of the area. Now, what are they trying to say? We need to calculate the shortest distance from R to line PQ. Shortest distance from R to PQ will be equal to the perpendicular from R to PQ. Let it be H. So area of triangle PQR would be equal to half into the base. So if I draw a perpendicular from R to PQ, I can take PQ as the base. So I can write area of triangle PQR is equal to half PQ into H. This is equal to half into 34.3 centimeters. So 34.3 into H is equal to 276.99331254 and so on. So therefore the value of H is 276.99331254 divided by 34.3 into 2. And if I calculate the value will turn out to be 16.151213 and so on. So if I cut it to 2 decimal places, it is 16.15 centimeters. And this will complete the problem. So remember, the perpendicular, the shortest distance from a point to any line is the perpendicular distance between the point and the line. So if I draw a perpendicular from here to here, and this is 90 degrees, then the area of this triangle is half into the base, which is PQ, into height, And that is the principle that we used. We calculated this area and equated it with half into 34.3 into height. And then we can easily calculate the value of h. So let us meet in another video. Until then, all the best. Thank you.